Inflammatory bowel disease or IBD affects 1.6 million people in North America and leads to $31 billion in annual healthcare costs in the United States. IBD covers a range of painful and debilitating autoimmune conditions such as ulcerative colitis and Crohn's disease, and the major risk factors associated with IBD include diet and smoking. However, the principal risk factor turns out to be genetics, since IBD can be inherited from one generation to the next. My name is Dr. Samit Watve, and I'm a data scientist with 10 years of experience in the fields of molecular biology and genetics. For my data science capstone project, I developed an algorithm capable of predicting IBD risk from genomic data using machine learning. This project was completed within 4 weeks using Jupyter Notebooks and the scikit-learn machine learning packages. My eventual goal with this project is to enable clinicians and researchers to be able to collect genomic data from newborn babies, apply machine learning to the genomic data, and generate a predictive risk score well in advance of any symptoms that may appear. For this project, I looked at the scientific literature and found a single dataset consisting of 2,600 samples of healthy and diseased individuals that also contained demographic information such as gender and family history. However, the major part of my dataset consisted of 200,000 genomic features consisting of A's, C's, T's, and G's. In order to make the dataset more manageable, I employed a feature selection strategy where I was only looking at those features that were most strongly associated with either the healthy or the disease phenotypes. And by applying the same process across the entire genome, as well as using a strict p-value cutoff, I was able to reduce the size of my dataset from 200,000 to just 400 prominent genomic features. Next, I applied a bunch of different binary classification algorithms such as KNN, random forest, logistic regression, and MLP across a total search space of 1,500 hyperparameters, and I scored each model for its ability to correctly predict the healthy or the disease phenotypes. My best model was an MLP classifier with an accuracy score of 0.83. However, the gold standard for measuring model performance in the field is a metric called ROC, area under the curve. So I went back to the scientific literature and pulled out AUC values from 3 prominent publications that relate to machine learning and IBD, and I was pleased to discover that my logistic regression model outperformed any of the published models and had an AUC value of 0.91. The key takeaway here is that I was able to go from having zero machine learning experience to industry-leading performance within just 4 weeks in a data science class. If I can do that, just imagine what I could do for your organization. The possibilities are endless. Thank you for listening to my capstone presentation, and if you're interested in finding out more details, just connect with me on LinkedIn or visit my GitHub page.